This is the mission 54 organized by Space Analog Station Habitat Marte. And today we will have the presentation of Paras Adlakha about the operation of a power station in Mars. Okay, Paras, you are welcome to share your screen. Now you are the host of the meeting, okay? Thanks.
Thank you, Professor. So now I begin my presentation. Welcome to 54th mission of Habitat Marte. I have a presentation regarding Powerstation. Firstly, I introduce myself. I am Paras Adlakha. I am currently pursuing BTech Aerospace Engineering from University of Petroleum and Energy Studies, India. So now I begin my presentation. These are some of the topics I'll be covering in my presentation, starting from internal design with from there what are the necessary technologies I have mentioned in my power station, from there to the guidelines which we can use on daily life on earth from my the technology which I mentioned in my presentation. So this is the external design of our power station. This was the design proposed by Yash Rathod in mission 47. Here I also included a cycle setup plant, which I'll be introducing in my presentation further. So basically, cycle setup plant will be connected to the power station, where a complete Brayton cycle engine will be installed here, working on the principle of supercritical Brayton cycle. Here we will be using SCO2 fluid as a part of the air, and power station will be directly connected to the engineering center and solar farm, as well as a nuclear power plant also. This is a 3D view of our Hybrid Marte, showing all the modules which are here, including power station and cycle setup plant. Coming to the internal design, all the facilities present a circumference shape with 8 meters of diameter and 3 floors. We are considering that each specific facility need to provide dormitory with beds for astronaut with our facility, small kitchen or a dining room, a necessary toilet, small vertical garden with plant for meals. The power plant cycle setup will be specially furnished with sound absorbing pyramid acoustic foams all around. The power plant will be working on 4 different concepts. The first one is solar farm, second one is a nuclear power plant, and third one is other possible methods of power generation which we can use on Martian surface. And then there is a maintenance of habitat secondary systems. Coming to the introduction for the power station, power is the major factor while designing a space habitat over a Martian surface. The most optimistic source of a power generation of Mars will be the solar radiation, because there is the solar radiance over the Martian surface is more than the Earth, and the direct use of solar power or simple power generation cycle like Britain or a Rankine cycle will not be efficient in a Martian atmosphere. So we have to use some other kind of cycle or a power generation mode on a Martian surface. The Martian atmosphere consists of around 95.3.2% of a carbon dioxide, which sow the seeds of our research. By making the use of this carbon dioxide rich atmosphere, we analyze the concept of producing the energy from supercritical CO2 hybrid power cycle, also called supercritical Britten hybrid Britten cycle. We are saying here Britten hybrid Britten cycle because we are going to use some other kind of combustion chamber instead of the conventional one, which basically use a propellant, the burning of a propellant. We are not going to use here in this hybrid Britain cycle. The man Mars mission will require a good amount of power generation, because a single trip for Mars requires around 30 months of time until they come back on Earth, due to different orbital properties of Earth and Mars. For carrying out in situ operations like drilling, production of oxygen, extraction of water, etc., on Martian surface, a power generating system with reassuring potential is required over the Martian surface. As I said earlier, the solar radiance over the Martian surface is more than as compared to the Earth, but still atmosphere block it by consideration amount. That's why the direct use of solar panels for generating the power will not be efficient on a Martian surface. So in our internal design, we are going to use some kind of equipment which will help us to extract the energy, which is ultimately will go in vain if we not use it. So the sound insulation and absorption. As we know, while producing energy from Britain, cycle produces a large amount of sound energy. The acoustic project of enclosure involves the selection of material to determine the type and quality of walls, surfaces, etc., so that a certain location is apt for one use. It involves avoiding an undesired level of incidence of external noise, and making the internal reverberation characteristic adequate for the desired use. So here, instead of using only acoustic material, we can use a coating of piezoelectric material over it, which will convert sound energy into electrical energy, and can be used for use this type of material in our dome shaped uh, cycle setup plant, which we can see in this picture. And this is a piezoelectric material. We can apply this piezoelectric material over this acoustic material, which will ultimately give us electrical energy um, after the conversion from sound energy. So basically it will um, generate electrical energy from sound energy. Now coming to the applied technologies, or the technologies which we are going to use for the production of power in our power station. Recently I proposed an idea in Mars Society annual convention with my team. The title of the project was next generation power generation next gen power generation for Martian life. So basically what we use the supercritical Britten cycle to produce the power required for space habitat or mission for Mars. The SCO2 cycle is used to increase the efficiency of the simple Britten cycle. We use CO2 SCO2 cycle here because we have an abundance amount of CO2 on in Martian atmosphere. It is assumed that the CO2 will be pre-compressed from the pressure of 610 Pascal, basically, which is the ambient pressure on Martian surface, up to the pressure of around 7,377.3 kilopascal to reach the supercritical condition. Basically, it is the supercritical condition for the carbon dioxide. So we are basically assuming that the CO2 will be pre-compressed to this much of pressure by the use of diffuser or some other kind of technology. It is used in a hybrid mode, means it will get heat input from a solar panel instead of a fuel based combustion chamber. So what I said earlier, that are not going to use the conventional combustion chamber here. We will be using hybrid. We will be using the combustion chamber in a hybrid mode, where we will be taking the heat from the solar panel or some other kind or from some other kind of fuel. The heated SCO2 is passed through turbine, which start rotating. As a result, the initial power cycle begins, and thus from this turbine, our electricity is generated, which can be used directly for consumption in a Martian habitat. In order to increase the efficiency of turbine, we are using here the regeneration cycle. We are not using the simple Brayton cycle or the simple a normal Brayton cycle. We will be using the regeneration cycle here. It is having an efficiency of around 42.6 percentage on Mars, compared to the 25 to 30% of efficiency on Mars on Earth in a normal Brayton cycle. So basically, why we are not using Brayton cycle on a on Earth, because we are not having that much of CO2 compressed to that, uh, so that we can take that much of CO2 up to the supercritical stage. But on Mars, we know that we are having abundance of CO2, so that's why we will be using SCO2 on Mars. So this is the graphical representation of the Brayton cycle. Here is the compressor. So this is the inlet of compressor, where it is written 1. We will be using compressor will be taking the fluid as a CO2 from this inlet, and after that it will go to the heat exchanger. Basically, heat exchanger is a combustion chamber where pressure remains constant, and before that the compressor will rise the pressure to the that around 10, which is around a pressure ratio of 10. And basically heat exchanger will be the place where we will be collecting the heat from the solar panel or any other kind of fuel. After that, this heated flow will go to the turbine, and after turbine it will come outside. But as we know, we are using here a regeneration cycle, so there will be another component called regenerator. Instead of going into this heat exchanger, some of the amount of heat will go to the regenerator, and after that it will come to heat exchanger again here. After the regenerator it will go to this. So basically this will reduce the amount of heat required in the heat exchanger, because turbine it basically turbine what do turbine basically reduce the temperature of the flow by expanding the flow. So temperature will so the temperature will decrease up to certain amount of level. But but that flow is also having some amount of heat, so we can use that heat in the regenerator and send it to the heat exchanger. All these heat exchanger and the regenerator work on a constant pressure pressure principle. So these are the inlet condition for a supercritical CO2. As I said earlier, the pressure for a supercritical condition of the carbon dioxide is around 7,377.3 kilopascal, and then there is a temperature of 304.13 Kelvin, and followed by density, specific heat at constant pressure, and the gas property of gamma around 1.29. So here is another more method of power generation. Power generation with supercritical SCO2 nuclear hybrid cycle. This was also presented by one of my colleague in the Mars Society convention. Basically, what we are going to use, we are not going to use solar panel for the heat for the heat requirement in the heat exchanger. Instead we will be using the nuclear fuel in the place of solar panel. So here are some of the challenges, like installation of a power plant on Mars. Nuclear reactor small nuclear reactor should be small and safe enough that can be transported to the Mars. Here we haven't assumed that there will be a pre-compressed carbon dioxide. Instead, we use the intercooler technology here to reduce to make the pressure of 610 to 7.7 MPa uh, from around 0.006 bars. So we assume that if we have taken some of the assumption here also. We assume that we are capable enough to transport all the required component on the Martian surface, as well as the nuclear fuel uh, on the Martian surface. We are capable enough to build a miniature nuclear reactor. We have manufactured a compressor, basically, which will be manufacturing on the Earth, and will be transporting to the Mars with a high compression ratio of around 3 pressure ratio of around 3 per cycle, or we can say a per stage. Then there will be we have a setup compressor entry that allows only carbon dioxide to enter the compressor and filter the rest. So these are some of the our assumption in this method of power generation. Solar cell power plant. Solar panel use the photons produced by sunlight to generate the direct current electricity. When the photons hit the panel, they are absorbed by the panel's semiconducting silicon material. During this process, electrons separate from the atoms and move around the solar panel. We have we can use sun power Maxian solar panel, which are the most efficient till date, which is giving around 22.6 percentage, which will give around 22.6 percentage of of efficiency on the Martian surface. We have assumed that the space habitat consumption will be around 170 kilowatt from one of the research of my colleague, and I have given the reference in the reference section. The total solar radiance on the Mars is around 592 watt per meter square. So we have calculated the power rating around 133.792 uh, of the solar cell we require. Coming to the fourth method of power production, which is a conventional power production from a nuclear fuel. NASA and US Department of Energy are collaborating to develop the next generation of nuclear generator with a focus of a crewed mission to Mars. The Kilo Power project of NASA aims to produce a nuclear generator with greater efficiency and higher output than those currently in use. Nuclear power has a long and successful history of use in space exploration. It powered the Pioneer 10 and 11 spacecraft that explored the solar system. uh, in the 1970s and continues to be used in a technology such as Curiosity rover, which arrived on Mars in 2021. Basically, the NASA and JPL used small nuclear reactor in the MSL, which is a Mars Science Laboratory, which was taking the Curiosity rovers from um the Leo to the Martian on the Martian surface. So we can use such kind of nuclear reactors on the Mars on the different places to produce the power power generation. And nuclear reactors are very reliable at generating electricity, capable of running from around 24 hours a day for many months, if not years, without interruption, whatever the weather or season. Additionally, most nuclear reactor can operate for a very long period of time, over 60 years in many cases. In 2019, Unit 3 and 4 at the Turkey Point plant in Florida were the first reactor in the world to be licensed for 80 years of operation. So we can use this technology of nuclear power production from the nuclear fuel, because it is very safe, and it can generate the electricity to the large amount of time from the small amount of fuel. So we can use this kind of power generation method on the Martian surface to produce the power. So here is another method of power production from the windmill. The output of the windmill depends on the turbine size and wind speed through the rotor. An average onshore wind turbine with a capacity of 2.5 to 3 megawatt can produce more than 6 million kilowatt hour in a year, enough to supply 15,000 average EU household with electricity. This is the data which we can which is taken from the observation on Earth. So, as we all know, on Mars there are many sandstorms, and the wind speed is very high on some kind of on some days. So we can use the technology of a windmill for the power production on the Mars. But on Mars we can use coating of piezoelectric material and crystalline silicon, which is a solar cell, on the windmill, which will ultimately used to produce electricity from wind as well as solar energy. Hence, it will increase the efficiency of windmill. The windmill will not be that much big as on Earth because of the thin atmosphere on Mars. Basically, the material play a good role while working in the field of power production. So here are some of the important material which are required under our power production mission as follows. Some of the acoustic materials will be required for the wall construction of the our cycle setup plant. Then there are some of the piezoelectric material which will be required for the coating over the acoustic material inside the walls of domes, as well as on the windmills. Then there will be polycrystalline material required for repairing our solar cells. Radioactive materials like uranium or plutonium is required for the power plant, and also some of the for the nuclear power plant, and also some kind of other materials will be required for the construction of both the power plant, the cycle setup plant, and as well as the nuclear generation power plant. A good communication and navigation system will help us by giving the data about nearby storm from satellite in a Martian orbit. It will guide us for turning on the charging mode of batteries, because as we are going to use piezoelectric material all over the habitat, and windmill for the power production. Because of the distance, is a substantial delay in a data transfer. So for the deep space mission, a good quality of antennas are required. near our habitat. Uh, Support technologies like robots and automated system for data collection and recycling practices are also required. Environmental control and life support system uh, are required for the astronaut while living inside the dome. Then there are HVAC systems. The protocycle technology is required for the 3D printing recycling process. The necessary tools for maintenance are also required. The battery backup for rover related activities and life support system are also required. So here are some of the possible resources to generate in situ for or transported from the Earth for making space habitat, and also for the manufacturing of some product. We can take the use of Martian regolith. Due to the presence of large amount of carbon dioxide in Martian surface, we can make the use of this CO2 in generating the electricity from supercritical cycle based turbo machinery, as I said earlier. So from here, I'll be talking about the management of our power station. The organizational structure will be like there will be the station chief. Then there will are three technicians required in our power station. The technician and the chief all must come from the background related from the science and technology, such as power system engineer and a mechanical engineer. Then there will be what the duties assigned to these uh, position of the astronaut. Power station chief is responsible for studying how the institute practices are going on, and he will be monitor each and every section of the power station, like solar cell maintenance, nuclear power, etc. Also, he is the person to be contacted directly from the Earth as well as other facilities in case of power related requirement. Technician One of the technician will work under the chief and is responsible for solar cell activity, also can be conducted in case of any tool or equipment when required. Um, uh, then the, uh, this uh, second technician will be responsible for carrying out the research and maintenance of nuclear plant. Also, he will be responsible for doing research on Martian surface related to piezoelectric material and related to power generation. The third technician will be responsible for carrying out operation related to supercritical and Britain engine power station. Coming to the necessary training required for astronauts of our power station. The basic training required are while working, the astronaut should keep in mind the sustainable use of space habitat as well as the resources. The technicians must be trained according to the field of work they are assigned, like working with nuclear fuel related equipment, working with Britain engine, and maintenance of solar cell farm. The piezoelectric material is required to be maintained regularly, so necessary training should be given to the all of the three technicians. These are some of the links of the videos which I have mentioned in my uh, which I have mentioned in my presentation. You can go and check it on the YouTube. The resources needed for 1 week for the four of our members are the food requirement depend on person and the amount of work that person do in a day. But the average daily requirements are around daily consumption of food per person is around 2 kgs. So for a week it will be around 14 kgs, and um uh, for the total consumption of food is around 56 kgs. The water requirement for a week will be around 84 liters. The guidelines to be provided to other facilities or whole stations are such like The basic guidelines should be followed by other facilities while using communication as well as 3D printed product required by them. Regular research and development activities between the facilities are required for the successful completion of the mission. Regular meetings are required between the chief of the facilities to run the mission smoothly without any problem. The solar panel can be made using 3D printing, where material can be extracted like silicon from the Martian surface. Some of the protocols we will be using our power station, like regular contact from the other station and earth wired DRS should be maintained. The structure of center should be monitored regularly. Nuclear fuel rod must be checked regularly. The spacesuit must be dried off dust each time the astronaut go out for the Mars walk. The data report should maintain and backup regularly. The tools and equipment should be placed back every time after the use. The Britain cycle engine must be maintained regularly. Uh, so here are some of the occupancy or entertainment related activities which we will be following in our power station. Regular social gathering to reduce the stress. Smooth music inside the space habitat will reduce the chances of depression during the isolation. The activities in the cultivation and social areas can be organized. For the protocols for the food micro production in our power station will be the food logistic must be checked regularly and calculated. The waste management system should be made in order to recycle it. The risk management is necessary to avoid extra losses of food items. So here are some of the technologies and output that could be applied to the Earth. We can use the technology of supercritical Britten cycle instead of the coal fire power generation on Earth. The waste material refilled 3D printer is the technology of Industry 4.0 on Earth. The dust removal system can be used in the activities like car washing, the places where people are mining, etc. We can use the supercritical SCO2 cycle on Earth with necessary changes. Guidelines to be applied to daily life on Earth. Waste management activities should be practiced regularly. The investment in research in today will give a result as a comfort and a betterment of tomorrow. To sustain life, new technology and development in industrial field is required. So these are some of the references which I used in my presentation, and this is my the personal contact. You can contact me, and thank you. Now I end my presentation.